Our focus standard for today's lesson comes from Grade 7, Statistics and Probability, Standard 8C, Design and use simulation to generate frequencies for compound events. So our topic is on probability, designing simulations for compound events. Our essential question is, how can we design experiments to simulate probability problems? This is my favorite video lesson and one of the last ones of the unit. So let's go ahead and dive right in. There's a few important things to remember for these types of problems, and what we're being asked to do is there are some probability problems where we would not be able to actually take the data, but we want to simulate what might happen in a random chance occurrence to generate some data. So when designing experiments for these types of problems, we have to choose materials that match the expected outcome. Then we need to determine an adequate number of trials. And lastly, we need a method for organizing data. So let's just take a look at one question, and then we're going to see how many different ways we could simulate that experiment. Because sometimes we don't have all the necessary supplies, so we want to generate a lot of different ideas. So here's the problem. We know that female guinea pigs have an average of 3 pups in a litter, and if the female guinea pig has a 50-50 chance of each pup being male or female, what is the likelihood that her pups will either be all male or all female? So we don't have access, or at least I know I don't, to a female guinea pig to do this research with and see what happens, and it would take a long time to look at the probability over multiple trials, right? So how can we represent this problem without using guinea pigs, but come up with an answer, an idea, generate some experimental probability? So let's take a look here. I'm going to give us some possibilities, and then what might it look like? So we could do this experiment with a coin toss, because a coin has a 50-50 chance also, right? It has a heads or a tails, so it has a 1/2 chance, like we do for the pup being male or female. We could do that with a deck of cards. It's possible to run a 50-50 chance with a deck of cards, a spinner, or a bag of marbles, depending on how you set it up. So that's what we want to say. We may not have access to all of these. We do in our classroom, so maybe we'll try it out. But let's talk about what else we would need to consider. So the coin toss, we would have to first decide which side are we going to use to represent male and which one are we going to use to represent female. So here I just listed it out as heads would be equal to male, tails would be equal to female. Could I have switched that around? Absolutely. The only thing I have to be careful of is that throughout my experiment, I decide at the beginning how it's going to be represented, and then I stick with that consistently through my experiment. So first we're just defining what the heads and what the tails would represent. Then we decide how we're going to do this. So it was an average of 3 pups in a litter, so we would need to flip the coin 3 times, 1 for each pup, and record each outcome. We mentioned that we're going to need an organized way to record this, so you could think back to our last couple of videos of ways to represent compound events. We can use lists, tables, or tree diagrams. So here's an example. We might use a table like this, right? So we would flip the coin once, record whether it was a heads or a tail, male or female, flip it a second time and a third time, recording our results, and that would be 1 trial. 1 trial is not enough times to make sure that this is an accurate experimental probability problem. We would need to run multiple trials. So we would need to decide an adequate number of trials. I went ahead and said 100 trials, and I'm going to use that throughout. 100 is just a good large amount without being overwhelming to do. So throughout these, I'm going to use 100 trials. So these are the 3 things. We have to define how the coin is going to be used to represent the male and female pups, and how many times to conduct it for 1 trial, and then record just how many trials are we going to do. So what do you think it's going to look like for a deck of cards? How might we do that? Well, one way to make sure that the deck of cards is representing 50 chance is to make sure that we use like red cards for one gender and black cards for another gender. Here I defined as red cards for male, black cards for female. Could have switched that around. However, this is just how I decided to do it for this one. As long as I'm consistent, I can use it either way. So then, how many times do we have to draw a card for one trial? Well, we could still use a table like this, so we're still talking about 3 pups. So for one trial, we would have to draw the card 3 times, or 3 cards for one trial, and recording the result and replacing the card each time. So in order to make sure the probability still stays 50-50, that there's 50, or half of the deck is shown for males and half the deck is for females, each time we draw a card, like we draw our first card, let's say it's black, so we'd say, okay, female, and then we need to put that card back, draw it again, and then shuffle it up, draw a second card, and then record that one, put it back, draw another card, put it back, shuffling throughout, right? So as long as we're replacing the card each time, we could use a deck of cards, designate which half of the cards are going to be for male and which half of the cards are going to be for female. And again, I'm going to go ahead and say we'd want to repeat this for 100 trials. Alright, so see if you can figure out what we should do for a spinner. How might we make a spinner work to simulate this experiment? Or how might we do this for a bag of marbles? Pause the video to think about that and jot down your ideas, and then let's compare. For the spinner, I laid it out as needing to divide that spinner down the middle, making sure they were equal halves. One half for the male, the other for the female, and I could just write that on there, or if I had a spinner of different colors, I would just decide which color was male, represent males, and which one represent females. Again, I'm going to need to spin that spinner 3 times, recording each outcome for one successful trial, and I'm going to repeat that for 100 trials. For a bag of marbles, it might look something like this, where I'm going to put half of the marbles that are alike, so like 10 green marbles to represent the males, 10 yellow marbles to represent the females. You could have chosen different colors or whatever, as long as half of them are the same and those represent the males, and the other half are a different grouping, a different category, and those represent the female. And then a lot like the deck of cards, we're going to draw 3 marbles one at a time, record the result, and replace the marble each time. Again, making sure that there's always a 50-50 representation in the bag before we draw a marble. So drawing 3 marbles one at a time, recording the result to be one successful trial, and I would repeat that for 100 trials. So here are 4 different ways that we could simulate the probability question that we started at with here, that matches the expected outcomes of a guinea pig having a 50-50 chance of having a male pup or female pup. We determined an adequate number of trials for each time, and we had an organized way of looking at and collecting our data. So I'm just going to end you on a challenge question to consider. So jot this one down into your notes, and then we'll discuss it in class. I want you to consider, it's a statistic currently that about 40% of the US population has type O positive blood type. So what is the experimental probability that at least one of the next 4 babies born in the US will have type O positive blood? So again, jot this down, and then here are the questions I want you to think about. So if we had to simulate an experiment to represent this, is it possible to simulate this probability problem with a coin toss? Why or why not? And how could you design an experiment for this probability problem using a spinner or a bag of marbles? If you come up with another way, that's fine too. But think about that jot the question down and your answers to it, and come ready to discuss that in class.